Okay, this is a continuation of Algebra 1, Semester 2, Unit 8B, Sections 9, 5, 9, 6, and 9, 7. Sorry, the battery ran low and I didn't notice that. Okay, so we have m minus 3 as our other factor on that problem. Okay, next one. You notice here we have a negative off the front side. You can't have a negative off the front when you're factoring, so you need to factor out a negative 1 before you can factor this. So it's x squared plus 10x plus 25. Now we go ahead and we factor this. It has a 1 on the front. So all that we need to do is think of our factors. We don't have to use the x game. So what would multiply to be 25 and add to be 5? We know that it'd be positive, and we discover it's 5 and 5. Do not forget to bring this negative 1 down. It is a factor. Now, x plus 5 and x plus 5 means that it's a perfect square, so it's x plus 5 squared and a negative 1 out to the front. Okay. Okay, here we have a 1 out front, and so again, you don't have to use the x game. You can go straight to your factors. We bring our leading variable down. Z times z is z squared. And now we ask what factors of negative 24 would subtract and end up being negative 2. Well, we know since it's a negative 24, one will be positive and one will be negative. Now we start listing them. 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's as far as we can go. Now we ask ourselves, do any of these have a difference of negative 2? We have, right here is a difference of 2. The one farther from 0 will have that sign, so that's the negative 6. That's the 4. Okay. Page number 5. Moving right along with these. Difference of two squares is factored in a really fun, really fast way. You could expand this out to realize that your middle term is a 0. And then you could ask yourself, what two factors will equal negative 64 and add to be 0? And if I think of all the factors of 64, which ones would subtract actually to be 0? I've got 64 and 1, 32 and 2, 3 won't go in there, 4 will go in there 16 times, 5 will not go in there, 6 will not go in there evenly, 7 will not go in there evenly, and so that leaves us with 8. You notice 8 and 8 have a difference of 0. So because that's negative, we know one's a negative, one's a positive. We bring down our first term, and now we have 8 times 8. These get really fast as soon as you can recognize that that's a perfect square minus a perfect square. I suggest that you just go right into the factors. So we have a perfect square minus a perfect square. We know one's going to be plus, one's going to be minus. And now we bring down the x, the root of it. We bring down y, the root of y squared. And there's your answer. 16x squared and 4y squared. (16x squared), the root would be 4x plus 4x minus 4y squared, the root would be 2y. Now there is a little problem in leaving that as your final answer. If you look at those two terms, you could still pull out a 2, which you do need to do. So out of this one we'd have 2x plus y. And out of this one we would have 2x minus y. I ask that you bring these 2's to the front and multiply them. So 2 times 2 would be 4. 2x plus y, 2x minus y. Okay. Here we go. Again, that's a difference of 2 squares. We could go ahead. I can see right from the beginning, just like I could on this one, see how you could take out a GCF. Let's go ahead and take that GCF out right at the start on this one to eliminate having to take that extra step at the end. So 4 will go into both of these. We'd get 4 a squared minus 16. We see it's still a difference of 2 squares, so we just bring 4 to the front and we go ahead and factor this down. Be a plus and a minus. A squared, the root of that is a and a. 16, the root of that is negative 4 and positive 4. Okay. On this one, difference of 2 squares. So we do our minus and our plus. Root of x squared is x. Root of 81 is 9 and 9. So those are very quick to do. Main thing is memorize that list that I gave you of the perfect squares, perfect cubes, so that you start being able to recognize those special things in the numbers. Very last thing in this section is asking you to solve quadratic equations when all you have to do is find the root. We draw the line down. All that we have is the creepy dude being raised to a power. So when we write our PIMDAs and we're going up it, like you've done in previous units, there's no add subtract with the creepy dude. There's no multiply divide. We get to the exponent. How do we undo an x squared? We want to get that x all by itself. Well, you might remember square root of a square is x. What you do on one side, you have to do the other, so you have to get a square root of 196. Well, the square root of 196 is 14 because you've memorized it off your list. But remember, it could also be a negative 14 because negative 14 times negative 14 is 196. Okay. So now we have this kind of a setup. We've got the creepy dude squared, the creepy dude not squared. We got a little bit of a mess here, and the only thought would be, hey, we've been factoring trinomials. Let's bring this 6 across and make this a trinomial and see if we can factor it. We might be able to. If not, we'll see if we can think of something else to do. Now, we know the leading coefficient is 1. So, do we have 2 factors that would multiply to be a negative 6, so it's got to be a plus and a minus, and they would add to be 1. I know my 2 factors, 3 and 2 would do that. 3 is farthest from 0, so it takes the sign of the middle. Then 2, and then x and x. Now let's double check. Positive 3 times negative 2 is negative 6. Positive 3 plus negative 2 is 1. So now we set each of these equal to 0. And the reason for that is because we know if 2 items are being multiplied and they equal 0, one of them has to equal 0. So when x equals negative 3, this equation is true. And when x equals positive, oops, I probably should show that to you. We bring that across, x equals positive 2, then that equation is also equal to 0. If you go back to the original equation, you plug in negative 3 squared, that would be positive 9, plus a negative 3 would be 6. If we take 2, 2 squared is 4, plus 2 would be 6. It always works if you plug it back in and check it. Okay, this last one, looks like we're going to play the x game again. Well, we don't have to play the x game, go straight to our factors. This is a positive 30, so the signs are going to be the same. They'll have to be negative in order to add to be negative 11. My 2 factors that multiply to be 30 and add to be 11 would be 5 and 6. So when x is equal to positive 5, or when x is equal to positive 6, this equation's true. That's the end of this section. Have a good night.